We are Little Shop of Physics, and we are live. This is our next installment of Little Shop of Physics Live. Welcome to 2021, and our first episode this season is the weather show. I want to just say a couple of words of introduction if there are people who are new. We're a group called Little Shop of Physics. We're at Colorado State University, and we do science, and typically we do science hands-on. These days, we're tending to do a lot more stuff virtually, but we're still providing resources to teachers and students. So go ahead and check out our website and see all the different things that we have to offer. And we particularly want to offer resources to teachers and share some ideas for how you could use some of these materials in your classes for your teaching, because we're educators, you're our people. So definitely try to connect with us. All right, and today we're going to be talking about the weather. And I'm going to start with a quick introductory demonstration. Now inside this container, I got a helium balloon. And I'm going to take this helium balloon and I'm going to cool it off. I'm going to cool it off by putting some liquid nitrogen on it. And liquid nitrogen is basically air that has been cooled off so much that it turned and isn't a gas, but it's a liquid. So inside this cooler, lots of liquid nitrogen. And what's happening is there's a helium balloon inside there, and that helium balloon is getting really, really chilly. It is getting really, really chilly. Now I have a question for you that I'm going to put in the poll. We're going to let it get really cold. I'm going to bring it out, and my question is this. When the balloon warms up, will it get bigger or will it get smaller? Will it get, when I bring it out and warm it up, or will it stay the same size? That is an option too. And I'm seeing about 60% of people are saying bigger, and about 40% of people are saying it's going to get smaller, with a small minority of people saying it's going to stay the same size. People who are in favor of the status quo is what I'm seeing here. Okay, we're going to go ahead and take a look at our balloon here. And first, what I'm going to do is I'm going to get it really, really chilly. I'm going to put it directly in the liquid nitrogen, okay? And when I do that, this balloon gets distinctly tinier. It's going to get distinctly tinier, and you can see it's actually going to be kind of wrinkly. Here's my balloon. And when it warms up, whoa, it's getting bigger. You can see that. It's definitely increasing in size, and at a certain point, as it gets bigger, it starts to rise. But it can't rise when it's smaller. So again, we bring it back in, we put it in the liquid nitrogen, we get it nice and cold, and it's actually getting kind of crinkly, and now it's tiny and it is not floating. But if I bring it out and hold it up, I'm going to warm it up in my hands, it's getting bigger, definitely getting larger. And once it gets large enough, it's going to do what helium balloons do. That thing is going to head for the ceiling. So we warmed the gas inside that balloon up, and it got warmer. And when it got warmer, it started to rise. Okay. So now Brenna has something on this topic. I think Brenna's got some warming going on over there.
I certainly do, Brian. So here I have this black metal colander. And I have the sun. We're calling this lamp here the sun. And I have Barringtina Jr. right here. Okay.
So a little bear. And that's like a beach bear, right? Hanging out at the beach, hanging out in the sun.
Yeah. And we have heat from above from the sun. And we also have heat from below from the Earth's core. And if I put this little spiral thing over, it spins because the hot air rises.
Whoa.
And it pushes that spiral.
That thing is spinning like crazy, and that's just from the hot air that's rising.
Yes, it is.
And if someone wanted to make one of those spirals, is that something you could make?
You certainly could. You just need scissors and a piece of paper and a little string, and you cut a circle, and then you cut a spiral around, and then you just poke a hole in the top and hook your little string in there.
Then you take that spiral and put it over top of your heated surface, heated by the sun, and it goes like crazy. And of course, that's kind of like the surface of the Earth gets heated by the sun. And when the surface of the Earth gets heated by the sun, it heats up the air. And when the air gets heated,
it rises.
It rises. Okay, next up, Maud has a demonstration for us, and Maud has got a freezer and refrigerator unit next to her, and Maud has got a spiral too, and we're going to ask a poll about what happens next. Now, Maud is going to open the freezer, and when Maud opens the freezer, cold air is going to come out, and the question is this. When Maud opens the freezer, will the air that comes out of the freezer rise, or will it sink? We're going to put out a poll, and everybody weigh in on the poll. Tell us what you think. Oh my gosh. Sinking is way out in front with 74% of the vote. Maud, everybody says it's going to sink.
All righty, let's see.
Maud opens the door of the fridge, and look at that spiral go. That air is a sinking. That air is a sinking out of the freezer. So the cold air is going to sink, and the warm air is going to rise. Absolutely. Well done. And of course, this happens in the atmosphere. This is really, really important. Air gets warmed up near the surface of the earth, and it rises. And when you have air that cools, it's going to sink. This drives the motion of air in the atmosphere. And Brenna has a little demonstration to show us how this works.
Well, Brian, aren't we going to show our lantern first?
Oh, shucks. I totally forgot. Sorry, Brenna.
You forgot about our
we have a big version
lantern.
of this. I totally spaced that out. So here's a little thing we did out on the oval to show hot air is rising. We had some hot air from this burner, and we put it inside this big red balloon, and the big red balloon rises and heads for the sky. But as it rises, it cools. And so at a certain point, that thing came back down to the earth, and it ended up landing in a tree, but it just looked like a holiday decoration. So I think we just took the campus and decorated a little bit, so I think that that's quite acceptable. And now Brenna is going to show us a demonstration of rising and falling, not air, it doesn't look like air, but rising and falling.
Well, it's water with this pearl swirl fluid in it.
And if you wanted to make something like that at home, you don't have to have that special fluid. What could you use?
No, you don't. You can use this swirly shampoo, which I had to put it in a mason jar because the bottle decided to give up on its life. But you can use this fancy, well, it's not really fancy, you can buy it anywhere, swirly shampoo, or you can order a jug of this pearl swirl fluid. And all I have is this dish here. And what I'm going to do is I'm going to turn on the heat a little bit. And water is a fluid just like air. And so it's going to form heat patterns pretty similar to air. And here, if we take a look for a minute, see if we can get some convection cells going.
And that swirly fluid will show us the motion of the liquid. Oh, I'm seeing some action starting to happen there.
Yep, it's starting to move. So what's happening is the water on the bottom is heating up, and then it starts to rise, just like the air. Gets to the top, it cools, and then it sinks back down. So that's what you're seeing, these little bands right here. That's water rising, cooling, and then sinking again. And this happens in our atmosphere as well. And a lot of times that's how we get storms.
Oh my gosh, I've seen patterns like that.
Yeah.
I look down at the clouds from an airplane.
Yeah.
And so that's just air that's like rising and falling and making this pattern in the clouds. What? That's
definitely
crazy.
This also happens in a pot of water when you boil it.
Oh
so
my gosh. That's fantastic. And we have a video that shows this even more compellingly, don't we?
Yes, we do. We did a time lapse of this. Pretty awesome.
Oh my gosh, look at those patterns that show up there. That's fantastic. Oh, and then, Brenna, you put in some red food coloring, which somebody asked for. They said, use the red thing. Oh my gosh, and look at it go. The red was going out, and the other stuff is coming in.
We put some ice in there, and what you see, that resulting swirl, is actually a storm, which is kind of neat. So you get this cold spot and a hot spot, and you get a swirly storm.
Oh my gosh, that's fantastic. And so the storm idea, that's something we're going to come back to. Now, Maud has got a fish tank here. And Maud, you did a little experiment with that fish tank. Tell us what you did with that.
Yeah, so I did this with water, but it works the same way with air, and it's we just call it like a cold front, hot front experiment. And so I just had a medium-sized fish tank, and I had this plastic little separation here. And if I just put it in the middle, and then I just put cold water on one side and hot water on the other, and then lifted this out to see what it'll do. And actually cold air, like we saw before, wants to sink. So we'll just see what happens here.
Okay, so we got the blue water, which is cold, and the red water, which I assume is warm. my gosh, got your cold water, got your hot water. Remove the barrier. Whoa. And that cold water totally goes and pushes its way underneath the hot water.
Yeah, and so this in your atmosphere and in weather as your connection is how surface winds happen. This is what happens.
Oh my gosh, you get the cold air and the hot air, and you get the different temperatures, and it causes things to move a little bit sideways. That is awesome. Here's the thing, though. It's really hot near this equator, and it's really cold near the poles. So how come the hot air at the equator just doesn't go up to the poles, and the cold from the poles doesn't push its way down to the equator? Why doesn't that happen? Oh my gosh, and Ahmad, I think, has a demonstration to illustrate this idea.
I do. So the reason that this doesn't happen is because of something super cool called the Coriolis Effect.
Nice, thank you, Ahmad.
You almost slipped up there,
I
Mark.
know, it's not a force.
Okay.
It is definitely an effect.
It's an effect.
And it's when, so I've just got this tray here, and got a little ball on the tray, and if I slide it away from me, it goes straight. And this is how, just imagine this being air moving, for example. But if I reach back here and I spin myself and I do the same thing, I'm just going straight, but then the ball goes all the way over there.
Oh my gosh, and now we've got a video that shows a Ahmad's eye view of this, right?
Oh, yeah.
So here's the thing. Ahmad rolls that ball in the tray, just goes in a straight line. But now if the chair starts to rotate, it looks like the ball is going in a curving path. Of course, it isn't really going in a curving path. What's going in a curving path is Ahmad.
It's me.
Ahmad's going in a curving path. But it looks like that ball goes in a curving path, and there's this Coriolis effect. And of course, the Earth is spinning, and because the Earth is spinning, we have a situation where the air, as it moves, is going to start to spin as well. And I want to show a little video of that. So we had this situation right here. I'm going to annotate this so we can see where I've got a heat lamp over here, and I got ice in the center. And this ice in the center, that's like the pole. That's like the Earth's pole. And the heat lamp at the center, that's like the Earth's equator. And I'm going to put blue and red food coloring in, and we can watch it move. So red food coloring is where it's hot, blue is where it's cold. And then look what happens. The fluid doesn't just go from the cold place to the hot plate. It does, but as it goes, look what happens. We end up getting all these little storms that develop. Look at that little storm right there. Whoa, that is fantastic. You get a little storm. And so the blue doesn't just go straight out. As it goes out, it starts to curve, and as it starts to curve, it makes these little swirly storms. And we're going to let that play and kind of like see what happens. And we got these amazing storms. Check it out. Look at that. And you can see those waves of blue. And something similar happens in our atmosphere. And one of those waves of blue kind of like comes down as far as Colorado. That can be a time when we get a nice winter storm. But the cold tends to stay right up near the pole. And you can see the hot is staying near the equator. There is some motion. And something like this happens in the Earth's atmosphere. So the global circulation is a little bit more complicated. Now, next thing we're going to do, we talked about clouds earlier, and we want to talk about clouds in a little bit more detail. But before we do that, Brenna is going to show us a little something about air. What do you got there, Brenna?
So I have a bottle, and it has a tire fill on the top. And what I did is I forced air into this bottle with an air compressor. When I forced the air in, I was doing work on it. It was coming in here, compressing, and this bottle heated up. When the bottle heated up, as soon as I released the air, very quickly, that air had to push the air out here out of its way. So it was doing work on this air, and thus the bottle cooled. So air that has to spread out and do work on surrounding air cools, expanding air cools, and the air that it's pushing out of the way heats up.
You know what, Brenna? I don't believe you.
Yeah, we're not seeing it, Brenna. It looks like...
Come on, Brian. You're the one that told me about this. Well, we have a thermal camera anyway.
So here's our thermal camera view. And Brenna, tell us what we got going on here. Oh, there's our compressor.
Yep, there's our bottle, there's my air compressor.
Pumping it up.
Pushing air in the bottle. It doesn't want to. Because I'm putting work on the air, it starts to heat up.
It got pretty toasty.
Yep. And then I took a dum-dum sucker to release the air.
Wow.
You can see as soon as I release the air, it gets really dark because it's cooling off significantly.
That is awesome.
Yeah.
That is awesome. And this is actually part of how we make clouds. And we're going to do a quick demonstration here. And this is something that teachers, you could do in your class if you want to show how we make a cloud. And I'm going to add something to this bottle. There's a little bit of water in here, in the bottom. And there's a little bit of air. And I'm going to add to it some smoke particles by having a little bit of, there we go, got a match. I'm going to let that burn out. And I get some smoke. And I have some particles of smoke inside the bottle. And those are going to make what we call condensation nuclei, on which little cloud droplets can form. And then I'm going to do just the thing that Brenna did. I'm going to pump air into the bottle. I'm going to compress it. And in the atmosphere, this happens when air sinks. And when air sinks, it gets compressed, and it warms up. And this bottle got perceptibly warm. And then I'm going to take this bottle, and I'm going to turn it like this. And that warm bottle is evaporating some of the water. And so now I've got a bottle full of warm air and water vapor. But if I let the air out of the bottle, Brenna, tell us what happens to the air when I let the air out.
Well, it pushes out of the bottle, it starts to expand, and thus it cools off.
And the air cools. In the atmosphere, it'll cool when it rises. So when air rises, it cools. And when it cools, it starts to make a little cloud inside my bottle. You can see it got a little bit cloudy inside there. It got a little bit cloudy inside there. But we have a better view of this, and I also put a light source behind it so we can see it even better. So we got this video where I made a cloud in a bottle with a light source. You can see the cloud better, but the other thing you also see, and Adam, I'd like to do the one with the light behind it. Yeah, let's do the one with the light. So we do a cloud in a bottle, and it's got a little bit of a light behind it. And the light behind it is going to show us some rainbows. And you see rainbows like that sometimes in the atmosphere. All right, so we're going to make a cloud in a bottle. And you can see the cloud form. And when cloud forms, you can see that amazing rainbow halo there. So we made a cloud. And then you get this amazing rainbow colors, and you can see the air swirling, and you can see the colors. Sometimes you see halos like that around the moon, which is really, really cool. So when air rises, it cools, and we make clouds. And whenever you see a puffy cloud in the summertime, it's on top of a column of rising air. Now, when we look at clouds, you know what color they are. But Brenna's going to do a little cloud experiment. Brenna, tell us what you got going on over there.
Well, I have a jug of green water, and I'm going to put this little humidifier in there. But first I want you guys to guess, what color is the cloud in this bottle going to be?
Oh, so that little humidifier element is going to break the water up into droplets.
Yep.
It's basically going to make a cloud, and then the question is, what color will the cloud be? We're making it with green water. Ooh. Green is way out in front. We got 60% of the people say the cloud is going to be green. 23% of the people say the cloud is going to be white. Blue is up there with 15%, and red is a distant fourth. Well, I think we got a difference of opinion here. We got to do the experiment. Let's see what we get.
I guess we do. So if I plug in this little humidifier,
what?
You can see the cloud that it is creating is white. And this is because when light hits the little droplets of water, it does not get absorbed whatsoever. It all bounces back. So you get all rays of light, red, yellow, orange, green, purple, blue, all the colors of the rainbow bouncing back, and that light that bounces back shows us white.
So you used green water and you made a white cloud, which
Yes,
is kind
I
of
did.
awesome. Oh, but here's another question. Sometimes clouds appear like they're white, sometimes they appear like they're gray. Maud, tell us what's going on with that.
So here I've got set up, I have a little wax block with 2 different layers of wax that's supposed to represent a cloud here. And if I shine my little source on it, it's a little bit brighter, but you can see, I can actually see maybe a little bit better. If
Actually, I think it's better without the light.
Yeah, if
Yeah.
I just don't even turn on the
Yeah.
light. You can see that the top layer is pretty brightly white, and then the bottom layer is gray. It's got a little airplane up here and a little car down here. And so what happens is that the light is coming from the top here, and it just doesn't reach the bottom. So the bottom is gray, but it's not actually gray. They're both white.
So take that thing and show it so we see gray on the bottom, white on the top. And then hold it up so we can see it well. And if you flip it over, go ahead and flip it. Yeah, now it's still gray on the bottom, still white on the top. That's awesome. And so clouds, if you're in an airplane, the color of the clouds is white. But if you're underneath, the clouds could look gray. If you have a really thick deck of clouds, they could look that great. And just not as much light makes it through. Most of it gets reflected or scattered, like Brenna talked about. That is awesome. But another related question to that is this. When light scatters off the water droplets, it does one thing, but light also scatters off the molecules in the air, and that's responsible for another optical effect in the atmosphere. And I'm over to Brenna to talk about that one.
Yeah, so the molecules in the air are pretty close together, and I have a glue stick to model the atmosphere. And I have 3 different types of light. I have blue, which you can't really see. I have red, and then I have just a plain old white light.
And it looks like when you put in that white light, the stick is blue at the bottom.
Yes, and basically what happens is these molecules in the atmosphere scatter the blue light more than the red light, and we have an excellent video to show you guys how that works. Let's see if we can get it up here. So basically, what's happening is the blue light is scattered more than the red light, which is why you see a more blue hue at the bottom of the glue stick and a more red hue at the top. The red light actually makes it all the way through the glue stick, and this is actually how sunsets work, and you can see that where I shine the red light and the blue light together. The blue light stays at the bottom, the red light comes out at the top, and that's how you get sunsets.
Oh,
It's
so
also
the sunlight goes in,
Yeah.
and then like the red is the only color that can make it through, and the blue gets scattered out, so we end up with the blue sky and a red sunset.
Yes, exactly.
And Brenna demonstrated that using a glue stick, which is kind of awesome. And I'm going to show you something else you can demonstrate this with. Okay, if I look between my fingers, I have a thin piece of skin right here, and this thin piece of skin right between my fingers doesn't have much pigment in it. And it appears pretty white, and the reason it appears white is the same reason that clouds appear white. I'm going to go ahead and shine light through it, and when I shine the light through it, what I see is light is distinctly red. And what's actually happening here is this is a sunset. This is like a sunset in my hand. The red light is able to make it through, the blue light's not. And so this is a way of demonstrating that phenomenon. I don't even need a glue stick, I'm just using my hand for this. And I'm sure kids have tried this before with a flashlight, and it's scattering. Really, the materials that make you up are clear. You're made up of water and collagen, to a first approximation. The skin is here. And those are both transparent, but there's some scattering that happens. And so that's a sunset in my hand, which is kind of awesome. Now, when we ask people about weather and what they're interested in weather, the main things people want is really, really dramatic weather. And one thing people want to know about particularly is lightning. I have a little device here that can make a big difference in voltage. If I spin these discs, I get a big difference in charges between those two. I get a little spark that jumps right here between those two things. And when the spark jumps, I hear a little crack. I get a little bit of lightning, and I get a little bit of thunder. And we can see both of those. But that's not how lightning gets made in the environment.
No, it does not. So we have basically how you need lightning to work. You need a difference of charges. So here I have a tube filled with different grains of sand, and it has these little diodes on the front, which are just little light bulbs connected together in series. And the big grains of sand have a different charge than the little
And I
grains of
just realized
sand.
I left Maud out. Shame on me. So we have different size grains.
Yes.
And when the different size grains rub against each other, and when things rub against each other.
Yes, we'll do that first. I didn't even notice
I
either.
totally-
Poor Maud.
I'm being bad today.
You were thinking about Mod 2, not Mod 1.
So here goes Maud, and Maud's got a little karaoke machine that's been modified, as it were.
Yeah, I've just got a little speaker here that likes to be quite loud, but so when I'm standing on the carpet right now, the molecules in my shoes are making bonds with the molecules in my carpet. But if I hold this and I jump, the noise.
Oh my gosh, we're hearing a lot of noise out of that. Oh my gosh. And that's just picking up the static that Maud is making when she's walking across the carpet.
Yep.
And so that's a separation of charges between shoes and carpet. We can also get a separation of charges between sand grains.
Different grains of sand. And sorry, Maud, I was... But the big grains of sand have a different charge than the little grains of sand. And that difference in charges creates a electrical current. So Adam, I think he has a video of this working in the dark because you can't really see it in the day. But this is basically lightning in a tube, and you can't hear any thunder because the tube does not let any sound out.
Wow. Well, and so when you shake that, oh yeah, I see the little flashes. I see the little flashes of light. And
Yep.
that's a separation of charges from the sand grains. And in the cloud, that happens when you have not grains of sand that rub together, but when
But
you have
droplets of
ice
water.
crystals.
Yep, and ice.
crystals
Yep.
rub together. And you have different sizes. You end up with a separation of charges. That's how you get your lightning. And as Brenna said, you don't get the thunder because the sound is not able to make it out of the tube. And we talked with Carly Cassidy about, who's with Fox 31, about, she's a meteorologist down there, about what was her favorite weather thing. And she said she wanted us to tell people about heat lightning. And people sometimes say, if you see lightning in the sky and you can't hear it, they say it's heat lightning. But it's just regular lightning that's so far away. There's not such a thing as heat lightning. It's just regular lightning so far away the sound doesn't make it. And so you see the lightning, but you don't hear the thunder. And that's where that phenomenon comes from. Awesome. Now I'm going to show you how we make thunder. And we're also going to do a thing with water and a thing with liquid nitrogen. So inside here, I've got this liquid air. This is liquid nitrogen. And this is breathtakingly cold. This is breathtakingly cold. And what I've got here is a container of hot water. And I'm going to take that container of hot water and I'm going to pour it into the liquid nitrogen. And then what's going to happen is I got something hot meeting something cold, and we're going to get a big cloud, but also listen for the thunder.
Woo!
Oh, that was good. Oh, that was
Oh my
good.
goodness.
That was good. That was good. And you heard the thunder, and the thunder is because I had a dramatic expansion of the air. Had a dramatic expansion of the air happening there. And so I
Brian, it
ended up
looks like
getting
you're in
that
a haunted
thunder.
house.
And I also had condensation of water vapor that's in the air. So I got a little bit of a thunder thing going on here. I got a little thing of a water thing going on here. I got liquid air inside there, and I got water that I poured in. This is a great introduction to our next topic, because our next topic is going to be water. And we're going to be back next Friday, because next Friday, our local Poudre School District, kids are still remote. We'll have another show for you. After that, your teachers and the district will tell you what we're going to do. We are going to stay on the air the whole semester, so if you're watching us, count on seeing us for the rest of the semester. We're going to do things a little bit differently, work with classes. Stay tuned for what that's going to look like, but also stay tuned for our next show, which is going to be all about water. All about water. I want to say thanks to everyone who took part today. I want to say thanks to Brenna.
Thanks, you guys.
Thank you to Maud.
Thank you, everyone.
Thank you to Adam and Patrick for making everything work behind the scenes. We have our technical support making things go. There is Adam working away, handling the Facebook, handling all of our different streams. And Patrick is the guy behind the video camera. Thank you all for joining us for the weather show. Next week, got the water show. We'll see you then on Little Shop Live.